You know, when we picture planets, we usually think of these perfect, beautiful spheres, right? Just gracefully orbiting their stars. Well, about 1,800 light-years from us, there's a planet that's getting so squeezed by its star's gravity that it's been warped into the shape of a rugby ball. Seriously. This is the very strange case of WASP 103b. Okay, so let's get to know our main character here, WASP 103b. It's what astronomers call a hot Jupiter. It's a gas giant, about 1.5 times the mass of our own Jupiter, but it is living dangerously close to its star. How close? Well, it whips around its sun in just 22 hours. To put that in perspective, Mercury, the fastest planet in our solar system, takes 88 days to do a lap. So yeah, this extreme closeness creates some really bizarre effects.
And the absolute most dramatic of those effects is its shape. The incredible gravitational pull from its star is just constantly stretching this planet out. So instead of being a sphere, WS-103b is what we call tidally deformed. It's been squished and pulled into this oblong, kind of egg-like shape.
So this brings up a couple of huge questions, right? First, how is this even possible? And second, how in the world can we know the exact shape of a planet that is thousands of light years away? Well, the answer to both lies in very carefully measuring the faint dimming of its starlight. So, how do we actually see this from so far away? It's really an incredible piece of astronomical detective work, and it all starts with a technique called the transit method. The basic idea is actually pretty simple. When a planet, like WASP 103b, passes or transits in front of its star from our point of view, it blocks a tiny fraction of that star's light. By measuring that dip in brightness with some really powerful telescopes, astronomers can create a graph that we call a light curve. And that little graph can tell us a huge amount about the planet. Now, here's where it gets really cool. The shape of the planet actually changes that light curve. A normal round planet creates a clean, sort of U-shaped dip in the light. But a rugby ball-shaped planet? That's different. As it moves across the star, the amount of surface area we're seeing changes just a little bit, creating these super subtle wiggles in the data, especially right as the transit starts and ends. And those tiny wiggles? That's the smoking gun for a deformed planet. And when I say subtle, I mean this signal is incredibly small. The precision you need is so high that Dr. Jacques Lescar, one of the astronomers on the team, said it was incredible that the CHOPS Space Telescope could even pick it up. But just detecting the shape, that was only the first step. The next challenge was to figure out what that shape tells us about the planet's insides. And this brings us to this really fascinating piece of science that connects the planet's shape to what it's made of on the inside. It's a concept called the love number.
And get this idea is not new at all. It was actually developed way back in 1909 by a British mathematician named, you guessed it, Augustus Love. He came up with it to study how our own Earth gets deformed by the gravity of the moon and the sun. Now, over a century later, astronomers realized they could use that exact same idea for a distant exoplanet. It's just amazing.
So what is a love number? Well, in simple terms, it's basically a measurement of a planet's rigidity, or I like to call it its squishiness. It tells astronomers how much of the planet's mass is packed down into a dense core versus how much is just spread out in its gassy outer layers.
I think the best way to imagine it is to think about squeezing a tennis ball. A really stiff, rigid ball isn't going to deform very much, right? But a softer, more elastic one is going to squish a lot more under the same pressure. The love number is just a way of measuring that for a planet that's being squeezed by its star.
Okay, so here's the bottom line. A low love number means the planet is stiff, rigid, probably with a dense, heavy core. A high love number means the planet is puffier, more squishy, with its mass more spread out. So by measuring how much WASP 103b was being deformed, scientists could actually calculate its love number and basically peek inside. So what did the love number of WASP 103b actually tell them? This is where the story gets even weirder. So let's look at the puzzle pieces. First, we know the planet is about 1.5 times the mass of Jupiter. Now, logically you'd think, okay, more mass means more gravity, so everything should be pulled inward, making it a more dense, compact package. But here's the problem. Even though it's more massive, the planet is almost twice the size of Jupiter. This means it's incredibly puffy, or inflated, with a really low density for how much it weighs.
So when the astronomers calculated its love number, they were shocked to find it was really similar to Jupiter's. This meant its internal structure,
how its mass is spread out between its core and its outer layers, should be a lot like Jupiter's too. And that, well, that just didn't add up at all.
Here's the paradox. A planet that's 50% more massive than Jupiter should have a much, much stronger gravitational grip on itself. It should be denser, more rigid, and have a lower love number. But it doesn't. So what in the world is going on?
There's really only one conclusion that fits all the facts. The only way for WSP-103b to be so massive, yet so squishy, is if something is puffing it up from the inside. And the most likely culprit is the intense, relentless heat blasting from its nearby star, which has caused the planet to become severely inflated, kind of like a giant hot air balloon.
But, like all great scientific discoveries, this one solved one puzzle only to open up a brand new one, pushing us right to the very frontier of what we know about planets outside our solar system. You see, all those tidal forces should be causing WSP-103b to slowly spiral inward toward its star, where it'll eventually be destroyed. But the observations seem to suggest the exact opposite might be happening. Its orbit looks like it's actually getting wider. Nobody's really sure why. It could be the pull of another planet we haven't seen yet, but for now, it's a completely new mystery.
And answering questions like that is going to require even more powerful tools. While we found a lot of these hot Jupiters, new instruments like the James Webb Space Telescope, well, they offer a level of precision we have never had before. The JWST can measure these tiny effects with unbelievable accuracy, which might just help us solve the mystery of WSP-103b's strange orbit and finally understand its inflated nature.
The discovery of a rugby ball-shaped planet is just such a good reminder that the universe is far stranger and more wonderful than we can possibly imagine. It really makes you wonder, if a planet can be this weirdly shaped, what other bizarre planetary secrets are still out there, just waiting for us to find them in the starlight?